So I just introduced to you on Thursday the imaginary number I. Remember, if you guys, well, in case you don't remember, the letter I represents the square root of -1. So that's how we get rid of negatives under the radicals. And then you guys should know that anytime you take, like if you take the square root of a number, so square root of 9 is what? 3. And then if you turn around and you square it, what's 3 squared? It takes you right back to the number that would have been under the radical to begin with. So if you know that I is the square root of -1, but then we square it, it just goes back to the number that was under the radical. Okay? You guys literally just said the square root of 9 is 3, but then if you take 3 and you square it, you're right back to the number that was under the radical. Okay? And that's because squaring something is the inverse of square root. They even sound similar. Squaring and square roots are inverses, just like addition and subtraction are inverses. They undo one another. Okay? A complex number, they call it complex because it'll have like a constant, which is considered to be the real part of your answer, and then it'll have this imaginary part. I know it's imaginary because it has the letter I. So a complex number is two pieces. It's real and imaginary. Okay? That's just, so we call it complex because it has both. And what we're going to do is we're going to take things that look like this. Of course, there would be numbers there, like 5 plus 3i. And we are going to add them, subtract them, multiply them, and divide them. Okay? So take a look at the bottom. We're going to start with addition and subtraction. So I am first going to do a problem you guys would have done back in Algebra 1. Okay, let's just say in Algebra 1, I gave you two expressions, and there's a plus sign between them. So if I have 5x plus 1 plus 3x minus 4, addition we like, okay? So what would you guys do to get your final answer there? That's not multiplication. This is addition. You only distribute when you're multiplying. You just add what? Add your like terms. So we're going to add the x term. So 5x plus 3x, 8x. And then you would add the two constants, 1 plus -4, -3. And this would have been your final answer. So anytime you guys see me write CLT, combine like terms, when you are adding, it is nothing more than combining what looks the same or looks alike. Okay, so now if you have a problem like this one down here, we have a constant and we have an imaginary part, a constant and an imaginary part, plus sign between them. Wouldn't we still just do the exact same thing? We can only add real numbers with other real numbers, and we can only add imaginary numbers to imaginary numbers. So we would combine like terms. What's 5 plus -2? 3. And what's 7i plus 6i? 13? 13i. Yep. That's your final answer. See, that's not too bad. You are just combining like terms. That's all you're doing. And I will tell you, you know, we got rid of textbooks a long time ago, but in a textbook, they would specifically say that when you write your answer, you should always put the real part first and then the imaginary part. That's why I wrote it this way. In all honesty, does it really matter? I mean, if I wrote 13i plus 3, isn't that the same thing? I personally do not care which order you put it in as long as your signs are correct. Like, as long as you have both of them positive, doesn't really matter to me which one you put first, but the majority of the time you guys will see the real part listed first, then the imaginary. Okay? Is everybody okay with that example? Okay, well then back in Algebra 1, especially if you had me as your teacher for pre-algebra or Algebra 1A, anytime we had a minus sign, we still combined like terms, but what did I have you guys do first with subtraction? Yeah, we always turned it into addition because people tend to know their addition rules better. So we did keep, change, change. So you would have done like keep this set of parentheses the same. You would change the minus sign to addition. And then everything in the second set of parentheses also has to change. I don't care if there's just one term, two terms, 5 terms in this set of parentheses, all of them change. This is the one that gets overlooked. A lot of people forget to change the very first term. Okay, so what I would do, my first set of parentheses, I'm just copying down the exact same. But then my first change happens right here in the middle. I'm going to do that in a different color. So minus becomes plus, and then everything in the second set of parentheses also changes. So -2 becomes +2, and then the plus sign becomes a minus sign. So that's how you do keep, change, change. Normally, I do it right on the problem, like you guys would have seen me put a plus sign here and a minus sign here. But for your notes, I just want you to see it separately so you can see what it looked like originally and then what I turned it into. And now, this problem looks like this one did to begin with. It's got the plus sign between them, so just combine. 5 plus 2, 7. And then 7i plus a -6i, a 1i. Yep, and it's +1. Some of you guys don't put 1s there. That's completely fine. You could just write that as 7 plus I. It does not matter to me. They're both right. Questions before we go on to multiplication? Or no, I'm sorry. I think on the next page there's a couple of examples first. Once you guys have these two copied down, flip it over and try the 3 problems at the top. There's like an A, B, C, I think. Yeah. If you see a minus sign, do keep, change, change. So like A, you should be doing keep, change, change before combining. For B, I would keep the 7, and then I would change the minus, and I would change those. So you're doing keep, change, change on B. Letter C, you don't have to because these two are being added to 3i. So that one you can leave alone. Try them. Do keep, change, change on A and B, and then combine like terms. And then we'll compare.
What? All those numbers become negative then?
The 2 in there would, yeah.
The 2 and the 4 would be negative
Yep.
then?
So -2 minus 4i. Yep. Oh, that?
Yeah.
I have to buy the mini. I can never drink a full bottle. No, I don't care about that. That doesn't bother me. I just can't drink that much of. Mm-hmm. There they are. So this is what I was talking about before. See how I just changed it directly on the problem? That's how I usually do it. If that confuses you, just rewrite it. That's fine too. But I had to do a keep change. That made the 2 negative and the 4i negative. So 8 with a negative 2 is 6, and 3i plus negative 4i is negative 1i. Over here, I changed this to negative and this to negative. These are the only two that pair up to make 4, and then the minus 2i stays the same. Now your last one, I didn't have to change anything. 4 is by itself. Negative 6i plus 3i is negative 3i. I can talk over it. That's nothing. Okay, do we feel okay with those? Adding and subtracting? Because then we're going to do multiplication down at the bottom. We're going to go back to Algebra 1 for a minute. Let me think. Let's do x plus 4 times x minus 3. Okay? These are my favorite. Okay, so back in Algebra 1, I'm just making this problem up here, and then I'll show you the one down here. Back in Algebra 1, it should have been 1b. This would be a binomial times a binomial. So 2 terms times 2 terms. Depending on how long you've been in school, because some of you guys are older and you might remember this from your previous high school. When I first learned how to do this, they called it the FOIL method. So it was nothing more than a fancy term for distributive property. It was literally take the first terms, multiply them together, the outsides, the insides, and the last 2 terms spells FOIL, okay? They got away from using that term because that only works when it's a 2 by 2. So if you had like a 2 by 3 or a 2 by 4, you can't use that term anymore. So I still have some students who know that they're just supposed to do like distributive property, and that's all good and well. I, however, work much better when things are nice and organized. So I prefer to use the rectangle. So if I had x plus 4 times x minus 3, that's 2 by 2. I make a 2 by 2 square. And then the x plus 4, since it was listed first, I tend to put across the top. You could put that one down the side. And then x minus 3, I tend to put down the side just because it was second. But it doesn't really matter where you put it, but you got to have the signs. Like the 4 was positive and the 3 was negative. So don't drop that sign or you'll have wrong answers in here. Then what you guys would have done is you're distributing, that's all you're doing. You look at the top row, it's x times x squared. And then when you do x times 4, you put it in this box. What is it? 4x. Okay. Then you guys would go to the bottom row. And you're going to do the exact same thing, but we're going to do negative 3 times x and put it here. Negative 3x. And then this bottom corner is negative 3 times 4. Negative 12. So you would fill in the 4 boxes, and the reason I liked that was because right here, typically along the diagonal, you would have your like terms. So when you go to write your final answer, you kind of just start this way and go this way. So x squared is by itself. You would add these two together, which would make what? What's a 4x minus 3x? 1x. And then the minus 12 would just be at the end. I promise you, all of you that had 1b last term did that. That's multiplication. So you'd have x squared plus 1x minus 12. Okay? We are essentially about to do the same thing down here. There's one small difference, and it's because of the letter I. Okay, up here, when you guys took x times x, do you know the value of x? No, so we left it x squared. Down here, you guys are about to see what happens when we take I times I. It's just a little different. But here's two terms, here's two terms. So now I drew the boxes. You guys will have to draw them yourself when you're practicing, okay? But I put the 2 plus 3i across the top. And then down the side, negative 3 plus 5i. Okay, so here we go. Negative 3 times 2. Don't all speak at once. Negative 6. I'm going to take that out of my mouth. Okay, negative 3 times 3i is no different than doing negative 3 times 3x. It's just a different letter. So negative 3 times 3i, negative 9i. Okay, so top row is done. Bottom row, you have 5i times 2, positive 10i. Okay, now watch. Watch me do it before you write anything down. No, not that one. This corner. This is the special corner. This one's special. Okay? So what we would normally do is we would take 5 times 3, which is 15. Okay? If I have I times I, that's I squared. Yes? Okay. But back in Algebra 1, it was x squared, and we didn't know what x squared was equal to. Well, don't we know that I squared is equal to negative 1? We know that. So I squared actually has like a numerical value to it. So this I squared drops off, and it's going to be a negative 1. Like we're going to take 15 times negative 1, which is negative 15. So essentially, listen, don't make this more complicated than it really is. You do 5 times 3, which is positive 15, and then just make it its opposite. Because it will have an I squared attached, which will make it its opposite. That's all it does. So most of the time, you guys will see me on the outside of the box. You'll see me write like 15I squared, and then you'll see me put the number inside. It should just end up being a constant. Now let's write our final answer, because we still have to like do what we used to do in Algebra 1. The good, or not, I don't know that it's good, but back in Algebra 1, these two are like each other, but then aren't these two also like each other? Because now they're both constants. So we actually have two pairs of like terms. I always add my two constants together because that's the real part, and that's supposed to go first. So I would do negative 6 plus negative 15, negative 21. And then I would do these two, so 10i minus 9i is a positive 1i. Now that one's done. Okay? Good? Okay, let's do some more. Let's do 3 more multiplication problems. And then we'll finish with division, which again, we just turn into multiplication anyway, so. Bless you. All right, now, this one, is this a 2 by 2? Is that 2 terms over here? Okay, so if it's just 1 term on the outside times 2 terms, we don't need a box. This is just straight distributive property, okay? So if we take 12 times 3, we get, okay? And then we would have I times I, which is I squared. Okay, now don't do anything with that yet. We'll do it later. Then 12i times 2 be 24i. Okay? Now, look right here. What is this I squared going to make that 36 become? Negative 36 plus 24i. It's the only thing it does. It just changes the sign of the number in front of it. So if this had started out as negative 36i squared, I would have made it positive 36. You just always make it its opposite. Okay? Now, the next two are 2 by 2s. So I already drew the boxes for you. We'd have 6 minus 5i times 4 minus 3i. I'm just going to write them up here. I'm not filling in the boxes. I'm going to have you do that. I'm just writing this stuff on the outside, and then I'm going to freeze my screen to let you guys try to get those boxes filled in. And maybe what you do is just fill the boxes in before you, like, don't write your final answer, because make sure the boxes are right before you do it. So I'm going to give you guys just a couple minutes here to try it.
So you go back to negative there, right? The bottom corner one?
It started out negative, so the I squared would turn it positive.
Yeah, I'm not good at that. I don't remember those boxes like that at all. I didn't. There's no way I did.
I know he teaches them.
Because I thought the way we did them was we ended up writing it out like that.
Which you can if you do distributive property.
See, I don't remember us taking.
But you're still, but it's okay because you're still, I mean, you're still doing the same thing. You're still doing the same thing with me that you did with him. I might put mine in a box, but you still would get the same 4 terms. All right, so I'm going to start with this one in the middle. We have 4 times 6, which is 24. So make sure you guys just check what you wrote in here. Excuse me. 4 times negative 5i is negative 20i. And then bottom row, you guys just have to be careful. It's nice when everything's blown up so big because I can just cover that up. Just be careful when you do this bottom row. It's negative 3i times 6, which is negative 18i. And then negative 3 times negative 5 is positive 15. So look, this is what I would do. I'd write 15i squared. And I always write it on the outside because I know it's going to change. So if this is positive 15, you just stick a negative 15 in there and drop the I squared. And then you don't really need that anymore. Okay, how'd you guys do with those numbers? Did you get those terms? So when you combine them, we've got 24 minus 15, which is 9. And then negative 20i minus 18i is negative 38i. And that would be your final answer. You just put your constants together and put your I terms together. Okay, then for the last one, we're going to do 4 times 4, 16. Then 4 times negative 9i negative 36i. Then for the bottom row, 3i times 4, 12i. So I said, sometimes that bottom row, you just got to be careful. And then, okay, so now let's talk about that bottom corner. 3 times negative 9 is negative 27 with an I squared at first. But then the I squared makes it its opposite, turning it into positive 27. Are we okay? Okay, 16 plus 27, 43. And then if you have negative 36i plus 12i, negative 24i. Okay, good. All right, so addition, subtraction, multiplication, done. We just have division left. Okay, now like I keep telling you with division, I always turn division back into multiplication because then we can just do box problems like we were just doing there and we don't have to learn anything different. All right, so this is what division looks like. You guys know that the number on the bottom of a fraction, you can never have a 0, right? You guys know that? Like you can't have 5 over 0. 0 is never allowed on the bottom. Well, guess what else isn't allowed on the bottom of a fraction? Imaginary numbers. You're never allowed to have an I down here. So there is a way to get rid of it, and the way we get rid of something, we always use its opposite, right? So this is what we do. Pay attention. We are going to multiply the top and the bottom by the same thing. If you start with one fraction and you multiply by 5 over 5, it's going to look different, but it's still equivalent because you're multiplying top and bottom by the same number. Well, it's not going to just be one number. It is actually going to be this. So go ahead and write this down and I'll explain it in just a second. We're going to multiply the top and the bottom by 1 minus 2i. Okay, this is called, it's actually called the complex conjugate. Okay, what that means is the symbol in the middle, the operation sign, is the only thing that changes. So I can't say opposite, because if I said the opposite of this, technically this one should also change. All we're doing is changing the operation. Because think about what happens when you have a positive and a negative. Don't they typically cancel each other out somehow? That's what's going to happen here. By multiplying top and bottom by the complex conjugate of the denominator, it will cancel out our I term on the bottom. We'll still have an I term up top. That's allowed. You just can't have it on the bottom. Okay? So look. When you multiply two fractions together, you go straight across. So I'm going to show you this in two different colors. Like the bottom, I'll have, notice here, a 2 by 2. That's what the box is for, because up top, is this a 2 by 2? No, it's just one term by two terms. So up top, we're just going to distribute. All right, so let's talk about the top and then we'll worry about the box. Our new numerator is negative 2 times 1, which is negative 2. Yeah, let me just cover that up. All I'm doing is multiplying out the top. So negative 2 times 1 is negative 2, and then negative 2 times negative 2i. Positive 4i. Okay? So your numerator in this case was real simple because all you had to do was distribute. The bottom, however, we're going to have to use a box. So I'm going to just, we've already dealt with this. We changed our numerator. So now for the denominator, we have 1 plus 2i being multiplied by 1 minus 2i. Okay, 1 times 1, 1. 1 times 2i, 2i. Now look what's going to happen down here. Negative 2i times 1, negative 2i. And look, what do those two do? If you have a positive and a negative, won't they cancel each other out? That's good, because now our I terms are gone. Bottom right-hand corner, we have negative 2 times positive 2, which is negative 4 to start with, but it would have an I squared attached. So what is that going to become? Just 4. There's no I. It's just 4, just a constant. Okay, so the goodness, see, now you hopefully see why I did this, because it forced our I terms to cancel each other out. And all we have now on the bottom is 1 plus 4, which is 5. And that problem is done. So you have a numerator and a denominator in the final answer. Okay, turn the page. I'm really not going to do both of these. I'm probably just going to do the one up here because the one at the bottom would be done the exact same way, just with different numbers. Okay, so I wanted to show you one like this one here where up top it was just 1 term times 2 terms because all you needed was 1 box for the denominator. And then I want to show you one where, see up top there's 2 terms and on bottom there's 2 terms. So it's going to be a 2 by 2 up top and a 2 by 2 on the bottom. See how I made you 2 boxes? You're going to need 1 for your numerator, 1 for your denominator. Okay, so here's the hardest part. What am I multiplying top and bottom by? Well, this really isn't the hardest part, but which one has to change? Which is the one that we make the conjugate? Huh? The bottom. So it's going to be 4 plus 3i. And whatever you multiply the bottom of a fraction by, you got to multiply the top by. Okay, so now I really will do different colors. So orange is going to be my 2 numerators. Okay, I like to label things. This top box is going to be my numerator box. That will help you when you go to write your final answer because whatever's in the numerator box will go up top. And then we'll do the denominator and well, I'll do it in blue. So then this box down here will be our denominator. Okay? Ready? I am. Okay, so across the top, always make sure you guys are doing the 2 tops. Don't try to do diagonal stuff or top and bottom. It is just numerator times numerator. So 3 plus 2i times 4 plus 3i. We're going to do the numerator first. We're going to complete this one, put it up top, and then we'll do the denominator and put it on bottom. Four times 3 is 12. 4 times 2i, 8i. 3i times 3, you have a 9i. And then as soon as you get to that bottom right-hand corner, just make sure you slow down and think. Okay, we've got 3 times 2, starts out as 6. It would have the I squared attached, making that box negative 6. Okay, box is filled out. We do 12 minus 6 to get 6. So that's our new numerator. And then 8i plus 9i. 17i. Okay, so good news, numerator is done. Now all we have to worry about is the denominator, which I'm going to do in blue. Okay, so we have the two denominators being multiplied together, so 4 minus 3i and 4 plus 3i. What's 4 times 4? 16. 4 times negative 3i. Good. Then on the bottom, 3i times 4. Okay, good, because now don't those cancel each other out? Top right, bottom left, the I terms are gone. And then this corner, 3 times negative 3 is negative 9, and it'll have I squared attached, which will make it positive 9. So then all you have to do is add 16 and 9, and that is your new denominator, which is 25. 16 plus 9 is 25. Okay, now the only downside to me not doing this bottom one is I think the bottom one everything reduces. I just want you guys to notice, you know, you've got 3 terms here just like we did on quadratic formula today, remember? Remember when there were 3 terms right here, 3 numbers? If they reduced, you had to reduce them. This is the same thing. I mean, you've got 3 terms. If all 3 of them had something in common, you would have to reduce them. I think this one down here reduces, which is why I probably put this one on here. But just for instance, if you guys had, I'm just making this up. If you had an answer that was like 15 minus 20i over 30, what are they all divisible by? 5. So I would write that as 3 minus 4i over 6. Like I would just divide everything by 5, and then this would be my final answer. Okay? So always reduce if you can. Some of them will, some of them won't. Clearly these 3 terms don't have anything in common. So I'm not going to do that bottom. You guys can always practice that one if you want, but you're about to do a practice page that's going to have like 3 of them on there anyway. Okay? And that is the end of your first set of notes.